Hi, this is part 2 of a 4-part video series. In the last video, we saw that the surface area of a cone is given by the formula pi RL. And in this edition, I want to look at a frustum. A frustum is a piece of a cone. It's the piece of the cone without the point. This might look familiar if you've been to the circus. It's the base that the elephant might stand on at the circus. This is called a frustum. And the question we want to answer here is, what is the surface area of a frustum? And again, I'm interested in the lateral surface area. Lateral surface area means just the sides, not the circle on the top and not the circle on the bottom. So let's label our frustum. Let's call this L. The smaller radius on the top, I will label R1. And the larger radius on the bottom base, I will label R2. Now, if we know how to find the surface area of a cone, we should be able to find the surface area of a frustum by adding on a little cone to the top. So let me redraw that frustum down here. Oops. That's good enough. And let's add what we need to complete a cone. So this part is L, this radius is R2, and this radius is R1. Let's call this length a lowercase l. The surface area that we're interested in is the area of the big cone, the entire cone, minus the area of the small cone on the top. So that's equal to, using the formula pi RL, the area of the big cone is pi R2, and the L now is capital L plus lowercase l. And we want to subtract from that the area of the small cone, which is pi R1 lowercase l. And that's the area of our frustum, which is fine, but not really good enough, because we don't want a formula that requires us to know lowercase l. If you look at the original frustum, there is no lowercase l in that diagram. So I don't want my formula to rely on a measurement that is not part of my initial diagram. So let's look at this big cone and see if we can get little l in terms of big L and the other r's. So I'm dropping an altitude right down in the middle of the entire cone. And what I've done now is, do you see it? I created similar triangles. And what the similar triangles give us a proportion. They give us a relationship between the big L, the little l, and the big R, the R1 and the R2. So if I take the small triangle and the big triangle, I have R1 over R2 is equal to little l over little l plus big L. Now let's do a little bit of algebra here. Cross multiply, isolate the little l. I'm going to wait 10 seconds for you to try it on your own. Cross multiply and try and isolate the little l. How are you doing? Is this what you got? This is what I got. I got little l is equal to capital L times R1 over R2 minus R1. I hope we got the same thing, because now I'm going to take that little l and I'm going to replace this little l and this little l with that expression. Well, first I'm going to clean this up so I have only one little L. So my surface area is equal to, let's pull out the pi. So that's not bothering anybody anymore. And we have R2 big L plus R2 little l minus R1 little l. Or pi R2 capital L, that part's not a problem, plus little l times R2 minus R1. Now we're going to take this expression and sub that in for the lowercase l. We get pi R2L plus LR1 over R2 minus R1 times R2 minus R1. Oh, that's beautiful, because we have some nice cancellation right here. R2 minus R1 over R2 minus R1, and we're left with pi. Now I can pull out the capital L, and I could put things in order. R1 minus R2. I'm sorry, plus R1 plus R2. And I'm just going to rewrite this one last time as 2 pi L. I'm going to put a 2 on the top and a 2 on the bottom, because it's nice to see this where we're looking at the average of the R's. So the surface area of a frustum is calculated as 2 pi L. L is that slant height times the average of the radii. That's the end of part 2.